In this video, we will be talking about how you can use a graph to represent a function. If you're given a table that represents a function, each corresponding pair of input and output values forms an ordered pair of numbers, which then you can be used to plot on a graph. So for example, let's look at this input and output value. So the input value, which is x, is 1. The output value, y, which is 2. So that can form an ordered pair, which should be written as the point 1, 2. Your input value comes first, and then your output value. When you go to graph that on a graph, your input values are your x values, which is the horizontal line here. And so if our input is 1, that means I go all the way to where x is 1, which is right here. Now, the output value is 2, which is represented by the y values on the graph, so our vertical values. So I go to where y is 2, and I plot the point 1, 2, right there, that coordinate point. So this is just to show you the connection between tables and ordered pairs and graphs. We're going to look at 2 examples in this video of some problems similar to this. So this example tells us to graph the function y equals 1/2 x with a domain of 0, 2, 4, 6, and 8. Our very first step then to solve this problem would be to make an input and an output table. So to do that, I can make it horizontally or vertically. I'll make this one horizontally. So I'm going to make a table of my x's and my y's to separate just like this. Now, our domains that they gave us here are our x values. So they just told me what to put in my table for my x's. So I have 0, 2, 4, 6, and 8. Now, in order to solve for the y values or the outputs, I need to plug each of these x values that they give me into x in the equation right here. So the output when x is 0, so I'm going to plug 0 in for x. So I'll just do 1/2 times 0. So y equals, let me write it out here for you. 1/2 times 0 is going to be 0. So that means our output value is 0 when our input is 0. Now, let's look at this next one where x is 2. So if I have y is equal to 1/2 times 2, well, 1/2 of 2 is equal to 1. So y would be equal to 1 when our input value is 2. So that helps me the next step of my table. I'll just write one more out for you. So if we have y is equal, now I'm going to plug in 4 in for x this time. 1/2 times x. I'm sorry, 1/2 times x, which is 4. So 1/2 of 4 is equal to 2. So that means my output value would be 2 when x is 4. So I did the same thing, plugging 6 in for x and plugging 8 in for x. We know half of 6 is 3 and half of 8 is 4. So that's my input and output table. Now each of those on the table can be written as an ordered pair. So the first one would be the point 0, 0. Then we have 2, 1. Then 4, 2. Then 6, 3. And lastly, 8, 4. We can then plot each of those points on this graph. So the first one is the point 0, 0, which is right there. The next one is the point 2, 1. Now remember, the first value of my x's, which is the horizontal line at the bottom. 2, 1 would be right there. Next is 4, 2, then 6, 3, and then 8, 4. And we are done with that example. Hopefully that wasn't too difficult to see how you would make an input-output table and then plot the points on a graph. This next one says write a rule for the function, that means an equation. Write a rule for the function represented by the graph, and then identify the domain and range of the function. So I'm given this graph with the green points plotted right here. So what I want to do first is identify what those ordered pairs are and make a table for the graph, right? An input-output table. So I'll do that. I'm going to change this to green. So if I have my input and output, my x's and my y's, I'm going to look at each of these ordered pairs, each of these points. My first point right here, and we'll look at that one, is the point 1, 2. So my input x is 1, my output y is 2. The next coordinate point, you should see that it's 2, 3. So I put that on the table. The next one is the point 3, 4. The next one is the 0.45. And lastly is the 0.56. So I've just made a table for the graph. Okay, that was my first step. Step 2 to solve this would be to find the relationship between the input and the output. What is happening to each of the inputs to give you the output? Hopefully, after just looking at it shortly, you can notice that from the table that each of the output values is one more than the corresponding input values. So I'm just adding 1 to each of those x's. Does that make sense? So, I can write this down for you that the output values is just one more than the corresponding input values. Okay, so write it down so you can see it and hopefully make sense of it. Corresponding input value. Okay, so what that means is that y is going to equal whatever x is. So no matter what x is, all I have to do is add 1 to it to get my y. So that's my function rule, or the equation that would represent this function would just be y is equal to x plus 1. Because again, each of my output values is just one more than what my input values was. So hopefully that helps clarify how you would use tables to represent functions and graphs.